Problem number 14, it asks us to simplify by reordering the work in the correct steps. I think the easiest way to do this is just start working it out as if we didn't even have the steps, and then we can compare and see which steps were correct and which one needs to be reordered. And of course, when you do this actual assignment, you're gonna drag the steps into place here. All right, so let's start working this problem out. Now, keep in mind that rational expressions are simply fractions. So we follow the process that we would follow if it were normal, everyday whole number fractions or integer fractions. Which means in this case, we cannot start subtracting until we have common denominators. So we need to find out what do these two denominators have in common. And the first thing we're going to do is we're going to simplify this one, because it's possible that one of the factors of this quadratic could be that. And if so, then that means that we already have our least common denominator in this one, and we just have to go ahead and add to that. So I'm going to break this apart and see what's there. So we got x and x. So I've got -4. I need two factors of -4 that are going to add up to -3. And factors of 4 are 1 and 4 and 2 and 2. I know 2 and 2 won't give me 3 no matter what I do with those. But 1 and 4 can give me 3 if I make the 4 negative and the 1 positive. So we just found out that this factor happens to be part of this quadratic, which means this quadratic is our least common denominator. And I'm gonna go ahead and leave it out like that. So that means that this can be rewritten as x plus 1 times x minus 4, because that's the same as this. I'm just rewriting this quadratic using its factors. Minus, same thing, x plus 1, which takes care of that one, and x minus 4, which gives me my least common denominator. So that means my numerators are gonna have to change. Well, this one won't, because we already had the LCD, so this will stay 5x. So this sort of fits that, but this 3 is gonna have to change. What did I add or multiply to this? I kept the x plus 1, but then I multiplied x minus 4 in order to get the LCD. That means I need to do the same to the 3. So I have to do 3 times x minus 4. Because whatever you do to the bottom, you do to the top. Whatever you do to the top, you do to the bottom. So far, this does not seem to fit, because they did 3 times x plus 1 instead of x minus 4. Because see, we already had x minus 1 there. All right, and the only thing we added to that was x minus 4, which we had to do it there. So this doesn't fit. And also they have addition here. So that one doesn't seem to fit. There's a problem there. Now, when I get to this point, since I have my least common denominator, I'm gonna keep it, because remember, the denominators stay the same. So I'll keep my x plus 1 and x minus 4. But then I can go ahead and add these. Of course, I'm gonna do this work. So I'm gonna do my 5x minus, this is 3 times x is 3x. 3 times -4 is minus 12. So here, I end up with 5x minus 3x, that's 2x minus 12 over the same common denominator. So let's see what we have here. I see the 5x minus 3x. Well, in this case, it is gonna be plus 12, because we got a negative times a negative. So I didn't wanna almost miss that myself. So that'll be a plus 12 here. So here they have that top part and that bottom part. So this is good. And then they combine the like terms, 5x minus 3x, to get 2x plus 12 over that. This is good. And here it looks like they pulled it apart again. So we're gonna pull this out, because you don't do all this work and then go back up here and pull it apart, because this is not part of it. All right. Let's see here. Looks like they did. They shouldn't have done anything to this 5x, because we already had the common denominator, the LCD. So that means that should have stayed. They didn't have to do this at this point, so that won't be a part of it. Okay, and 5x minus 3x minus 4. And here, looks like they just, all I can see is they pulled it back apart. I don't think we need to do this part. This actually should have came second. So it looks like, let's see, trying to see, and again, you wanna order those. So this is, okay, but what order does it go in? Well, let's look at what we did. So we went from here to here. So I see this. So that's step one. And then from there, we went to this one, which is step two. And then here we went there, that's step three. Okay, and let's see, this is not a part of it. Nope, I don't see where that's a part of it at all. It looks like right here. Nope, that's not it. And this is not it either. So I only see 3 steps here. So it's just 3 steps. All right. Number 15. So here we're going to take 2 rational expressions and we're going to divide them. And keep in mind that when we divide fractions, we use keep, change, flip, which is the same as multiplying by the reciprocal. So we're literally going to keep this one. So I'll write this over here. So we're going to keep, let's start it over here. So keep the 9x squared minus 3x minus 2 over 2x minus 8. Change means change the division to multiplication. And flip means you just flip the fraction upside down. So you take the reciprocal of this fraction. We'll put the denominator up top and make it the numerator, and vice versa. Put the numerator on the bottom, make it the new denominator. All right. Now, the good news about multiplication, you don't need a least common denominator. But look at all of this. We really don't want to multiply all that quadratic times that linear function, that linear expression up top, because we end up with the cubic and a lot of work to do. Same here. We just get a longer polynomial string. Let's go ahead and see if we can simplify some stuff and cancel some things out. Let's try that first. So for this one, let's see, can we do anything here to pull anything out? Let's see if we can come up with the factors of this one and this one. And the easiest one is this one. We'll pull out a 2, we'll have x minus 4 left, which we'll be able to cancel with this x minus 4, so already that's helpful. Here I see we've got some x's in common, and we have a 6. We can pull out a 6x. That'll leave 3x minus 2 here. Now this is gonna take a little more work. So we've gotta use the AC method on this one right here, which is okay, because a times c is just, there's the a, there's the c, that's just negative 18. If I list the factors of negative 18 and to try to get a pair that will add up to negative 3, I'm already thinking 3 and 6. All right, one of them has to be negative because it's got a negative 18. And the one that will most benefit us will be to make these 6 negative. Okay, so what that means is we got to rewrite that as 9x squared. And for this negative 3x, the middle part, we're going to make this a, let's do a negative, well, a positive 3x, that's positive, minus 6x. So there's the 3, there's the negative 6, and then bring the negative 2 on over. If you recall, this is how we use the AC method. And then, of course, we factor out what they have in common. And here we've got 3x. That leaves x plus 1. Minus, I can pull a 2 out of here, and that'll leave x. Let's see. I'm sorry, that'll leave 3x. I'll pull out a 2 minus, I left my 3 off here, thank you, plus 1. Because a negative times a positive gives me a negative 2. 2 times 3 is 6x. All right. We know that the what's in parentheses had to match, and they do. So the factor for this will be the outside terms, which is 3x minus 2, times the inside terms, which is 3x plus 1. So that's how this will be broken apart. 3x minus 2 times 3x plus 1. And that's helpful because now we can cancel some things out, this and that. Now it's much easier to multiply the numerators and the denominators. So that gives us 3x plus 1 times, well, times 1, because there's only 1 up there, since we were able to simplify it. So we got 3x plus 1. And the bottom is 2 times 6x is 12x. Okay? So we can leave this as our final answer for now. We could break it apart some more, but we're going to go ahead and leave it.